So they can give us all kinds of different equations for functions. And in general, there's kind of two issues that we have to be careful of. Not everything you can just put any real number in for. But anyway, the two issues are, one, can't divide by 0. And then I'm just going to tell you the other issue is you can't take an even root, like a square root or a fourth root, of a negative number. Okay, so this first example, we have a denominator, right? It's a rational expression for the function. You got a numerator, that's fine, you can put anything there, but I can't just put any real number in here. Almost, but I can't put any real number in there. I can't put a 2 in, because if I put a 2 in, then I'm going to have 2 plus 1 over 2 minus 2. That's going to be 0. That's going to be dividing by 0. I'm going to have 3 over 0, and that's undefined. Okay? So that's what I can't have. Now, you might say, well, how did you know you can't have 2? Here's how you do it. If you have a denominator, and you're trying to find the domain, you're going to take that denominator, and you're going to find out when does that equal 0. And that's what you can't have in your domain. So you could solve this, subtract 2 from both sides, divide by -1. That's what x can't be. Now, how are you going to write all real numbers except 2? I mean, I guess you could write it out in words, all real numbers except 2. But in interval notation, it looks like this. From -infinity to 2, oops, but don't include the 2, and then from 2 to infinity. Now, if you want to know what that looks like on a number line, here's 0, here's 2. So we're saying don't include the 2, but everything this way and everything this way. And that's going to say all real numbers except 2. But this is what the interval notation looks like. Okay? So anytime there's a chance you'd be dividing by 0, you have to set those denominators equal to 0 and take those values out of the domain. Okay. The other thing we have to be careful of is we can't take an even root of a negative number. So this is a little bit different here. You're going to take, we have a square root here. You're going to take the radicand, 7 minus x, and you're going to say, hey, that can't be negative. That means it's got to be greater than or equal to 0. So whatever's under the even root, in this case it's a square root. A lot of times it's going to be a square root, but they could give you a 4th root or a 6th root or something like that. But usually it's going to be a square root. Okay. Because the square root's one of our basic functions. But anyway, you take whatever's under the square root, or the even radical, and you're going to say that has to be greater than or equal to 0. Okay, then you're going to solve that. So subtract 7 on both sides, divide by -1. That's going to switch the inequality. And so you're going to get x is less than or equal to 7. On a number line, so here's 0, here's 7. It looks like square bracket and then all the numbers less than 7. In interval notation then, it's from -infinity to 7 with a square bracket. Remember, we always go from left to right, and infinity and -infinity always get a parenthesis.